Hello, today we are learning about poly.05 through poly.07, which is basically the end behavior of different functions. And it's also, as you can see on the screen here, finding relative min and max. So I'm going to quickly go through here and show you how to do it using the Desmos calculator. First thing, we're going to be analyzing these graphs. So if the degree is even, meaning that the highest exponent is even, in this case it's odd if you look at my cursor, but if it's even, then you would use these behaviors. You'd look at the leading coefficient, and if it's positive, so the number in front, if it's positive, as you approach negative infinity, which I'll show you on a graph, it would be going up. And if you approach positive infinity, it would also be going up. Or if the leading coefficient was negative, then it would go down on both the left side and the right side of the graph. If the degree is odd, like in example 1, part A, where we're determining the end behavior. If you graph this, the leading coefficient, if it's positive, which in this case it is positive, then the left side of the graph toward negative infinity is going to go down, where the right side is going to go up. And if the leading coefficient is negative, let's see if we have one of those. Yeah, like part C, I'll show you that as well. But the picture of the graph, as you approach negative infinity on the x, it would go up. And if you approach positive infinity, going to the right, it would go down. So I already graphed these. The first one, part A, I have already here on the Desmos calculator, so I'm going to switch over to that. And basically, we're just determining the end behavior. So what should happen is, since the degree is odd, meaning the highest exponent here is odd, it's a 5, what should happen is either it's going to look like this, or it's going to go in this case, it's going to be the positive because it's got a positive 2, or it could look like this if it's negative. So it should go down to the left, up to the right. So let's take a look at what it looks like. Down to the left as you go to negative infinity on the x, and then it goes up as you go to the right toward positive infinity. So that is true. Part B, I already graphed that one as well, so I'm going to pull it up. But what should happen is the degree is even, so we should be using these two behaviors. Going up, up, or down, down. And since the leading coefficient is positive, it should go up, up. So here's what that would look like. I'll hide this one. We can even zoom out to get a better look, but using the Desmos calculator, looks like it's going up, up, to the left, up, to the right, up. And then your next one, it has an odd degree, and it has a negative leading coefficient. So an odd degree, negative leading coefficient, should go up to the left, down to the right. So let's take a look and see. Up to the left, down to the right. And you can zoom out if you want here on the Desmos calculator. It's going to keep going like that forever toward infinity. So you can write that in the other notation as well. I don't know what this notation is called, but on the x, as you approach negative infinity, the y goes down toward negative infinity, and as you approach x to the right, going toward positive infinity, the y value is going to go up as well. So that's what these red arrows are standing for. And then let's see, we already do part C, yeah. So let's go on to example 2, the only other example, and then we're going to skip these worksheet problems, and I'll let you go ahead and take the quiz. So find the relative max or min. Relative max or min, all that means is you could have more than one maximum or minimum. Like this goes to negative infinity. It also goes to negative infinity to the right. So a maximum, you could have more than one. Like here you see the highest amounts, there's 2 of them. It kind of goes back down on this U shape. So relative max just means that you could have more than one. And you could put both, or depending on what it's asking, you might only have to put one. Then the relative min is the same thing. It's a minimum value, but since this goes to negative infinity, it's going to be relative. So it's not actually the most minimum value, but that's why we call it relative. So for part A, if we were to graph this, y equals x to the third minus 4x squared plus 6, which I did graph it, you're going to see, if I zoom in here, it's got a relative max and a relative min. So if we're trying to find those on the Desmos calculator, you literally just hover over it. You can click and it'll stay on the screen. But it looks like 0,6, and then you get some decimals down here. And that's what we have as the answers. So the relative maximum will be the highest value, 0,6. And then the min Relative min would be the lowest value, which we've rounded here, but there it is. Same thing on this last one. So I'll put it up on the screen as well. X to the fourth plus 6x cubed plus 8x squared. It appears two relative mins. Here's one. Here's the second. And then it has a relative max as well. So it looks like we get some decimals there, but you literally just write them down, and that's how you do it on Desmos. If you're using the TI-84s like we have in class, I'll show you in person how to do that. What you all are going to do is go to Google Classroom. There should be a link to the Desmos, or not Desmos, but your Delta Math quiz. I'm also going to attach a review for Poly.00 through Poly.07, which is what the quiz covers. And I'm going to attach a video of those being worked out by one of the other algebra teachers. But send me an email if you need anything, and good luck on the quiz. The due date it needs to be done by Monday at 3:10.